Welcome to Chapter 2, Section 2.4. We're going to discuss percentage of error. This is important when you're considering weighing, measuring a liquid or weighing a solid, especially when you're compounding or when you're mixing a very small sample. They might have a much smaller margin of error. We're going to look at margin of error and percentage of error. And it's important to remember when you're weighing these that the weighing and the balance are going to appear to have weighed correctly. However, they're all going to vary just slightly, so it's important to be able to calculate the percentage of error. If we turn our books to page 53, let's look at example 2.4.1. You can see on the marker board when we're looking at finding percentage of error, we're always going to take the amount of our error divided by quantity desired times 100. Now, if you're looking at amount of error and you need to calculate that, you're going to take the actual amount and subtract that from the quantity that's desired. So if we look at example 2.4.1, we are to dispense 120 milliliters of a liquid. The original measurement is 120. When you double check the amount using a more accurate graduated cylinder, the actual amount is 126 ml. What is the percentage of error of the first measurement? Okay, so first we need to find the amount of error, so we're going to take the actual amount and subtract it from the quantity desired. 126 minus 20, so our amount of error is 6 ml. So now we're ready to find our percentage of error. We're going to take the amount of error divided by the quantity desired, which is 120 ml. Whoops. And we're going to multiply that by 100. 6 divided by 120 times 100 is going to give us 5%. And 5% is usually the generally accepted range for error, depending on the item or product that you're compounding or measuring. So if we turn to page 55, let's look at a couple of the problem set questions. Calculate the percentage of error for the following measurements. Assume that the measured amount is equal to the quantity desired. Number 1, the measured weight was 185 milligrams, but the actual weight is 189 milligrams. First thing we need to find is our amount of error. 189 minus 185 is 4. So now we're ready to calculate our percentage of error. Always putting our amount of error on top and our original quantity desired on the bottom. And if you divide these two, it comes out to 0.021 times 100 is 2.162, but we're going to round that to 2.16%. All right, let's look at number 2. The measured weight was 500 milligrams, but the actual weight is 476. Okay, so we need to calculate our amount of error. We're going to subtract these two, and that's going to give us 24. Now that we know our amount of error, over quantity desired, which is 500, and we're always going to take that times 100, and that's going to work out to 4.8%. All right, let's look at number 3. The measured weight was 1,200 milligrams, but the actual weight is 1,507. So I need to calculate margin of amount of error, 1,507 minus 1,200, and that is going to give us 307 milligrams. So now that we know the amount of error, we can subtract that from the amount desired times 100. and that is going to work out to 25.583%, and we're going to round that to 25.58. Okay, pretty straightforward once you get comfortable plugging in the formula. Let's look at a couple of different other ways we can calculate this. Let's turn to the next page, page 56, and look at number 11. Determine the percentage of error for the following measurements and identify those within a percentage error of 3%. So that's going to be the magic percentage. The measured volume was 3 ml, but the actual volume was 2.6. So let's find the amount of error. Subtract these two and we're going to get 0.4 ml. Okay, so we know that 3% is also 0.03 in decimal form. We're going to take that times the measured volume, 3 ml, and that gives us 0.09 ml. So this is going to be our max margin of error. If we take 3% times 3, we know that anything we measure that's going to be greater than this number is going to exceed our 3% limit, which of course 0.4 ml is much greater than this, so we know that we're well above our 3% mark. Let's look at another one. Number 12. The measured volume was 12.5 ml, but the actual volume was 12.1 ml. Okay, so we're going to take this, subtract it from that, and that leaves us with 0.4 ml. Now we need to calculate what our 3% margin of error is going to be, so we know 3% is 0.03 times our measured amount, which is 12.5, and that's going to work out to 0.375. And if we look, we know that 0.4 is greater than this, so this is not within the margin of error. Let's look at another one, number 14. The measured volume was 3.2 ml, but the actual volume is 3.29. Okay, so actually we should write this the other way to subtract it properly. And that is going to work out to the amount of error of 0.096. Whoops, I'm sorry, 0.09. So now we need to find out what our 3% margin of error is going to be. So we're going to take 0.03 times 3.2. And that is going to work out to 0.096. So if we look at our 3% margin of error, we can see that this is within that. So yes, it is within our 3% margin of error, and this measurement is okay. All right, let's do one more. Do number 15. The directions for number 15 are a little bit different. Determine the percentage of error for the following measurements and identify those within a 6% margin of error. So the measured weight was 150 milligrams, but the actual weight is 149 milligrams. So if we subtract those two, we know that that's a difference of 1 milligram. So now we need to find out where our 6% margin of error lies. So we're going to take 0.06 times 150, and that is 9. We know that 1 is less than 9, so yes, we are within our 6% margin of error. Okay, so it's really just a matter of plugging in the formulas and getting comfortable working through those. If you have any questions, feel free to post them to the discussion Q&A. And finish out the rest of the practice problems on your own. It's always good to work through those, and good luck with the rest of the chapter.